Hello everyone. So this is the first module of the first week. So in this module, what I'll be doing is to introduce you to the various terminologies that exists in the area of software testing. What we would be using in this course, clarify the basic terms and tell you what are the various types of testing, the various methods in testing. We'll also look at various activities in testing and see what this course will deal with. So here is an outline of the course. So to begin with, we'll clarify on these terms which you might have heard about: verification, validation, and testing. And I'll tell you what we will deal with in this course. We'll also look at a whole set of related areas briefly and clarify what this course will cover. There are several terms and terminologies related to testing. What is a test case? What is an error? What is a fault? What is a failure? So I'll introduce you to all these testing terms and we will see what they mean. And then in testing, there are several methods of testing, several types of testing, several phases of testing. You might have heard terms like white box, black box, functional testing, usability testing, performance testing. So we'll see what these various terms are in the classification of testing. I'll end this module by introducing you to various testing activities and tell you what our course is going to focus on. IEEE maintains a standard glossary of software engineering terms in this particular standard called STD 610. So as per that standard, what is verification and what is validation? Validation is something that you do at the end of software development or system development. You have your whole software or system developed, ready in place, and you want to be able to check if this software or system meets all its requirements. When you do that at the end of the development, then that is what is called validation. Verification deals with what you test or verify while developing software. So while developing software, you might go through various phases: phase where you define requirements, phase where you do design and architecture, phase where you write code, and a phase where you test. At each stage, you're dealing with a set of software artifacts. So the kind of verification that you do, wherein you check whether a particular software artifact meets the requirements that were established for that particular set of artifacts, then you do what is called verification. Testing, as we will see in this course, mainly deals with verification. There are several other related areas that you might have heard about. One of the most popular, or my favorite ones, is that of formal methods or formal verification. There are three broad areas that people work on within formal verification, namely model checking, theorem proving, and program analysis. Testing, as we will see in this course, we will not deal with model checking or theorem proving or program analysis. Towards the end of the course, we will see symbolic execution. A lot of symbolic execution is used in program analysis, but we will see it from the point of view of testing. Right? In fact, there are several NPTEL courses available in each of these areas, and if interested, you are more than welcome to go and see them. A related area where people also do verification is what is called modeling and simulation. Let's say you have a piece of hardware design or a system design or a software design. For hardware design, popular languages that you could use are VHDL, Verilog. So you have your design and then you model your design in this particular language and you run simulations to see if the design model that you have done correctly does the design as per its requirements, right? So you have a modeling language which is usually proprietary or open source. You model using that modeling language and run several different kinds of simulations to see if the design model meets its requirements. So that area is modeling and simulation, and the testing that we would see in this course will not deal with that also. Another related area is what is called accreditation. Now, what is accreditation? Accreditation deals with software that is safety critical and needs to be certified. Take, for example, a software that runs your plane, right? Like a typical autopilot software. Any company cannot say that I have written an autopilot software as per the normal requirements of an autopilot software. So here it is, take and run, right? So these autopilot softwares, being safety critical because they cannot afford to fail, they have to be audited and accredited by responsible authorities like FAA in the US, DGCA in India, and they demand a lot of additional testing. There is a separate process of accreditation for which there is testing needs to be done, but accreditation as it is we won't look at in this course. What we will look at is the kind of testing that people do towards accreditation and the algorithms behind that kind of testing. We'll move on to looking at various terms in testing. You might have heard of a lot of these terms: faults, failures, errors. What do they mean, right? So what is a fault? A fault is considered to be a static defect that occurs in software. A static defect in the sense the defect that occurs as a part of the software, not a defect that occurs when the software is executing. So this defect could be a function that was wrongly written, a function that was not written at all. It could be any of these, right? And then when a software with this static defect or fault is executed, there is a misbehavior or a wrong behavior in software that is observed, right? This wrong observable behavior is what is called failure, right? And when the software has a fault, you execute or run the software, you observe a failure, then the software is supposed to enter an incorrect state. The incorrect state in which a software enters, the software that has a fault enters, and a failure is manifested, is what is called the error in the software. This is a small piece of history thanks to the book by Amman and Offutt on software testing. So they credit the term bug and fault to Edison. So apparently Edison used these terms first. So he talks about his inventions and he says there's a lot of excitement when you initially invent something, and then comes a bug or a fault, which he calls difficulties. And he says they show themselves and it takes sometimes a lot of effort to fix them, right? And the term error is credited for its first use to the first programmer whom you would have heard of, namely the lady Ada Lovelace. So when she was programming using Charles Babbage's analytical engine and punch cards, so she says that there could be an error. So this is considered the first use of errors, and he says this error could make the cards give wrong orders. As far as this course is concerned, we'll use all these terms synonymously: fault, failure, error, bug, defect. They will all be used interchangeably and synonymously. They'll all mean that there's something wrong in the software artifact that I am testing. Another important term that you need to know and get it clarified right now, that we will use throughout the course in testing, is when we say testing, the first thing that we have to do is to write a test case. What is a test case? Test case typically has two main parts. It gives inputs to the software artifact that is concerned, and it also says when I give this input to the software and execute the software on that, what is my expected output, right? So test case has an input and what is the expected output. It is to be noted that if I test a software artifact like code, I always give only inputs to the code in the part of the test case, and we typically don't give values to internal variables, to output variables, and so on, right? So now I give this test case, give inputs to the software, and run the software. The software produces the output, right? So the output produced by software is what is called actual output, right? So now what do we do typically? We check the actual output, compare the actual output to the expected output, and say whether they match or not. If the actual output matches the expected output, then you say the test case is said to have passed. If the actual output differs from the expected output, then typically in testing we say that the test case has failed. A failed test case indicates that there is a fault in the software and the fault has manifested itself by resulting in an error as per the terminologies that we saw. Typically, test case also contains things like an ID, because you need to track and record the test case, and people also maintain traceability information. What is traceability for a test case? Traceability tells you what are you testing this particular software artifact for, right? You might be testing a particular functionality in a piece of code. Who tells you to test for such a functionality? Where did that functionality come from? That functionality could have come from a set of requirements, right? So if it came from a set of requirements, which are the requirements that it comes from? So all this information is maintained in what is called traceability matrix or traceability data, which is also a part of the test case. Right, now we'll move on to looking at the various terms that are popular in testing and trying to gain clarity on what is what. So when I do testing throughout software development, right? And at each stage of software development, I could do a different kind of testing. So there are various levels of testing based on which phase of software development that I'm testing on. The right first testing that I do is called unit testing. Unit testing is typically done by a developer When he or she writes the code, they debug the code, they test the code then and there to see if the code is working fine as far as its requirements are concerned. These days, because of the stress on agile methodologies, developers are expected to do a lot of unit testing themselves. They don't really can have the luxury to pass things to a tester and say that you do it, right? And after unit testing, we typically do what is called integration testing. So what is integration testing? A developer again can do integration testing. So let's say a developer has written several modules of code and then they're trying to put together the code. What do we mean by putting together the code? Maybe the code is in different methods and one particular method could call another method, a procedure could call another procedure. So when you test these, focusing on these calls, these function calls, procedure calls, when you test the interfaces that occur between the various modules in code, then you do what is called software integration testing, right? There is also another term in integration testing where people take the software as it is written and put it as on the hardware that it's supposed to work on. Let's say you have a fairly large server, right? You put it on the server that it's supposed to work on. You're supposed to have integrated the hardware with the software. So when you integrate the hardware with the software and test the integrated piece of hardware and software, that is also called integration testing. So post integration testing, the next step that people do is what is called system testing. So in system testing, the entire system is put together. Let's say that take the case of an enterprise software, you will put together the server, the database, the web interface, the application server, the clients, and all the interfaces between them. And then you will test the end-to-end system from where the inputs come, what happens in the central system, what are the kind of main decisions that are taken, and how do they result in the outputs being produced. In embedded software, typically like a car or a plane, you would put the software as a part of the main system, which could be within the car or within the plane. The inputs will come from sensors, the main control algorithms will run by picking up the sensor inputs from the bus, and then they will produce actuator outputs. So this end-to-end software as a part of the system with the inputs and outputs integrated from their original sources, the entire system, when we test it, we call it system testing. After system testing, we believe that the system is more or less ready for release. The last phase of testing that people do is what is called acceptance testing. Here, you give the system to an end user and check if the system is working fine as per the end user committed requirements that the software or the system was supposed to meet. You might have also heard of a term called beta testing. What is beta testing? In beta testing, people specifically release what is called a beta version of software, right? When they release a beta version of software, they roughly mean that the software is working fine, but I may not have tested it for mitigating all the involved risks. So they are asking the users to start using the software and let them know if it has any bugs or defects. So when you do this kind of testing, then you're doing what is called beta testing, right? So let's take an example to understand this a little better. So let's say there is a main class, call it class B, which in turn has two classes A and B. Let's say class A has two methods, M1 and M2. Class B also has two methods, M3 and M4. Let's say a particular developer is working on writing code for method M2 or M1 or M3 or M4, just that method. So when the developer finishes writing code or while writing code, the kind of testing that the developer would do to test the functionality of just that method is what is called unit testing, right? So now if you look at this picture, method M1 happens to call methods M3 and M4. M3 in turn calls method M4. So when a developer puts together these two classes, all their methods, and tests features specific to these calls, right? Then the developer is doing what is called software integration testing. Let's say this after this integration testing, the developer puts together the entire system and tests at the level of the main class B. Then that phase of testing is what is called system testing. Right? You might have heard of all these additional terms in testing: functional testing, stress testing or load testing, performance testing, usability testing. What are they? We'll see them now. So what is functional testing? Functional testing is typically done to ensure that the software meets its specified functionality. What do we mean by this? Let's take a software that runs as a part of an ATM machine of a bank, right? What do you think is the core functionality of an ATM software? Core functionality of the ATM software could be the following, right? Once the user enters the password and the PIN, if the credentials match and if there is sufficient balance left in the user's account, then the amount that he or she has requested to be withdrawn should be provided to the user correctly, right? So ATM is meant to do just this, and when I test a software to check if it meets its main intended functionality, then I do what is called functional testing. Another kind of testing that is popularly done is what is called stress testing. So here what happens is that the system is meant to be up and running and available a lot of times, and sometimes the system experiences what is called peak input conditions. For example, recently the class 12 marks were released, right? So they were released on the internet through a web application software, right? So this system will experience what is called stress levels of input within 3-4 hours of the time and the date of release, when all the students would want to log in and check what their marks are, right? So when you test a system under these peak load conditions or input conditions, then you do what is called stress testing. The next kind of testing that you might have heard about is what is called performance testing. So what happens here is that here people do testing to ensure that the system meets its desired response time. It is fast enough. Like for example, when we insert the card into an ATM machine, we want the ATM machine to be able to respond with a welcome screen almost immediately, right? We can't afford to wait for 10 seconds, a minute or so, right? Performance testing specifies performance requirements on the system and checks whether all these performance requirements in terms of latency, speed, response time, etc. are met by the system. Next popular kind of testing is what is called usability testing. It's not only useful to have a great software system, but the great software system is meant to be usable by a user, which means the software should have a good user interface, right? It could be graphical or not, but the software should have a good user interface that is friendly. It should also be accessible in the sense by someone who's visually impaired, who's hearing impaired, right? It should be accessible. So testing that is done to ensure that a software is usable, has a good interface, meets all the accessibility guidelines, right, is aesthetic enough. The kind of testing that is done to do all this is what is called usability testing. Finally, one important term in testing before we move on is what is called regression testing. So when does regression testing happen? So let's say you've developed a piece of software and you've released it. So post-release, there is either a change to the software that you do or you add a new functionality to the software, right? Now it is obvious that you might want to first check if the change or the new functionality that you have added is working fine. And the second thing that you might want to do is that this change or the new functionality doesn't affect any of the other features that were already present in the software before this was done. Right? The kind of testing that is done to ensure that the software is working fine after modifying or upgrading is what is called regression testing. So when all these methods of testing, all the various types of testing basically follow two different methods in testing. You might have heard of these terms, black box testing and white box testing. So what happens in black box testing? When you do black box testing, you consider the software artifact that is being tested as a black box, which means you don't look inside it. Like when you test the code, you consider the entire code as a black box, give inputs to the code, execute the code, and observe the outputs to check if the expected outputs match the actual outputs. White box testing is the exact opposite. When I'm testing a piece of code with reference to white box testing, I look into the code and I test for requirements like, suppose there is an if statement in the code, can you write a test case that will cover this if statement? What does it mean to cover the if statement? It means that can you write a test case which will execute the then part of the if statement once, which will execute the else part of the if statement once. So similarly, when I white box test code, I could insist that you cover loops in the code. So let's say there is a while loop in the code. Covering the loop would mean that you write test cases to skip the loop, to execute the loop in normal operations, and to execute the loop on boundary conditions. So in summary, what does white box testing do? White box testing actually looks at the code, looks at the design, at the corresponding software artifacts, looks at structure, what does it have, what are the kind of statements, what are the kind of design elements it has, and then it tells you how to test it by looking at its structure. So black box testing applies to almost all phases of testing, all types of testing. It applies throughout the development life cycle. It applies for doing usability testing, performance testing, stress testing, and so on. White box testing is typically done only during software development. Once the software is ready, put together, the system is tested. Later on, when we test for other non-functional requirements like performance, stress, response time, good user interface, being accessible, we typically don't test it as a white box testing thing. We consider the system as a black box and then test for all these quality features in the software. Right? Now we'll move on to the last module where we look at the various activities in testing. There are typically four broad activities in testing. So we begin with designing test cases, because if you don't have a test case, then you can't execute it and you can't find errors in the software. The first thing is to be able to define or design a test case. Once I design a test case, I have to make it execution ready. That process is what is called test automation. After I make it execution ready, I can use a tool to actually execute it and record the results. After I record the results, then I do what is called evaluation or analysis to check whether the test case is passed or failed, and if it is failed and if there is an error, where the error is, and so on. These are the core technical activities in testing. Apart from this, there are several other umbrella activities, like you have project management and software development. Project management specific to testing is what is called test management. So there are test managers who design test teams, try to organize them. Another important activity that happens as a part of testing is what is called test maintenance and test documentation. A lot of testing, especially in the enterprise software domain, relies on reusing test cases. Extensive number of test cases are reused again and again to be able to test software, right? So how do I reuse a test case? I should be able to document it and store it well to be able to make it amenable for reuse. So the kind of activities people do to ensure that test cases are well documented and well maintained and available for reuse as and when they are needed broadly constitute test maintenance and documentation. So now moving on to test case design, this is considered the most critical job in testing. Why is it considered the most critical job in testing? Because the Pareto principle applies to testing, which means roughly 80% of the errors, a lot of the errors is focused on a very small percentage of the code, right? So if I don't design my test cases effective, what do we mean by effective in turn? If my test cases are effective, then they will find errors faster. They will find errors at all the errors or most of the errors that are present in software. There is no point in saying that I designed so many test cases and I tested them for days and days and your software is doing fine, right? So the effectiveness of test case design is in finding errors, right? And this needs domain knowledge. This needs knowledge about the system, about how it is developed, and typically cannot be automated. A lot of this course will deal with algorithms and testing techniques that we will use to design test cases. I'll give you more details about the precise kind of algorithms and artifacts that we will use in the next module. After you've designed your test case, the next comes converting these test cases into executable script, right? So you might have a test execution framework. You could use JUnit, you could use Selenium. These are open source tools that will let you do test execution, right? So you have to be able to make your test case ready for execution. Please remember, I told you that test case always talks about inputs. So suppose there is a requirement, white box testing requirement, which says that you go to a while loop, which is somewhere deep inside my code, and you test for coverage of that while loop. It might so happen that the while loop has got no input variables, it directly deals with internal variables. Now it's up to the tester to be able to design test cases and give test cases input values such that this while statement is reached. Not only is this while statement reached, this while statement is also covered under various coverage requirements. So, how does the tester go about doing this? The software has to meet two important criteria called observability and controllability. So, we look at these two concepts in the next module in this week. So after you've designed your test case and it's ready for execution, then comes the job of actually executing it and recording the results. This typically is almost always fully automated. There are several open source and proprietary tools that can do this really well for you. After you've executed the test case, again you need human intervention to be able to evaluate the result of the test case. So let's say the test case is passed, everything is fine. But if the test case is failed, that it indicates that the software is in an error condition. So where exactly is the error? Which is the erroneous components? Especially when you're doing system testing or integration testing, your software or system might be fairly large. It takes some amount of domain knowledge, experience, and human effort to be able to isolate the fault and facilitate the development team to be able to debug and test it once again. Right? So we would deal mainly with test case design algorithms in this course. So in the next module, I'll tell you what the algorithms are and what are the mathematical models, modeling software artifacts that we would deal with in this course. Thank you.